Alright student, let us start the today's topic, that is maxima minima, and by this we will also end up with the application of derivative part. And this complete chapter is actually broken in two terms. With respect to the boards, you are being asked word problems or the geometrical problems which are subjective in nature, and as per say your engineering entrance exams, they are not asking the very difficult questions, but the context and the type of questions are completely different. So I'll try to take both of them in this particular video so that you could do better at both of them. Okay, so let's first of all start with the basic of this particular topic. To understand the concept, let's take two very basic diagrams. So this is you can say it's a downward parabola that I have taken, right? It's a downward parabola, and this is the case of upward parabola that I have taken. Now there is a point C on this particular curve where you can see that the value that you will obtain will be the highest, right? This point here, and at this particular curve you can say that the value of this particular point FC here is minimum and here it is maximum. So in a way I can say here x is equal to C is point of maxima. This is, you all people know actually, this is point of maxima, and this will be x equal to C, here will be point of minima, right? So just to elaborate that how it is being done, how you calculate point of maxima or point of minima. So x equal to C will be called point of maxima, and FC will be called maximum value, right? So these two concepts have to be very clear, and here FC will be called minimum value, right? So point of maximum and maximum value, point of minima and minimum value. Okay, and how do you check a particular point is whether a point of maxima or minima? So again I would have to highlight something, that maxima and minima, if I talk about maxima and minima, is a property of a point, Okay, just remember this basic step. So if I want to check at whether x equal to C is a point of maxima or not, then FC should be greater than its neighborhood. So in neighborhood means just the left value and even the just right value, that is C plus H. So FC should be greater than both the left side value and the right side value, then this will become the maximum value. Okay, this is what is happening in this particular diagram. For the minimum part, the FC, that is the FC, what should be smaller than C minus H, that is the left hand side value should be greater than this, and it should also be smaller than the right hand side value. So just compare it with the definitions of increasing and decreasing, which are completely reversed, right? So this is the definition of a point being maximum or minimum, and this is pretty much useful when you have discontinuous functions. This is true for discontinuous function as well. Though in your syllabus you generally find continuous curves, but this is true for discontinuous curves as well. So for example, if I have to draw a particular curve, let's say this is the shape and something like this is happening, this is the point, and then after this reduces like this. So x equal to C here, right? X equal to C here is a point of maxima. Why? Because to the left it is having smaller value, and to the right also it is having smaller value, and it is completely satisfying this condition. So for discontinuity or discontinuous curve at that point, you can still have a maxima or minima. Though at mains level you people will not be asked these kind of concepts, so don't worry about them. Okay, now let's correlate with what we have actually did in increasing and decreasing. So let's say this graph is something sinusoidal in nature. Okay, it's a wave curve. So here from, let's say if I say this is the O dash point, from O dash to A, right? O dash to A, it is decreasing in nature. Then A to B, it is again increasing. B to C, it is again, yes, decreasing, and so on it is moving. So my point why I have taken this is, if you can see that A here, you will call it as minimum value. Then you will call this B point as maximum value. Again you are getting a trough. Again you are getting a, yes, peak here. This will be maximum. So how we define, we rather than saying maximum, minimum, what we say that they are local maximum values, local maximum and local minimum. Why I am using the word local? Because you must understand, because they are in their neighborhood, that is in their locality they are maximum and minimum. But for the complete function I do not know whether they are absolute maximum or minimum. We'll do that absolute maximum and minimum a bit later. So if you also consider this, that this is a point of local minimum. Why local? Because they are in their neighborhood, the minimum and the maximum values. Okay, so you have to use the word neighborhood. Got it? Got the concept? Okay. And if this is decreasing and this is increasing, so understand this also, that A, B, C and D, they are also called as turning points. Very important definition. You will find questions based on this particular concept, so that how a question can be framed, that A is a point, A is a turning point. So do not worry what is turning point. That means it is either a point of maxima or minima. Why? Because the graph is turning at this particular point. It was decreasing and now it turns and starts increasing. Here it was increasing and then it turns and start decreasing. So A, B, C and D are also called as turning points. We'll though also move ahead and see to it that they are also called extreme points. Okay, now if you want to highlight something that would define how you find a maxima minima point, for let's say in this particular graph we know that this at x equal to c, here the slope of the tangent is slope of tangent, that is f dash x, slope of tangent, right? If you can see, the slope of tangent is positive because the slant is something like this, right? So at the LHS left hand side, right, at the left hand side LHS, the slope of the tangent is negative. At the right hand side of C, the slope of tangent is positive, and the right hand side the slope of tangent is negative. Can you see? So somewhere if you say that the graph is continuous and differentiable, so when you say that you have moved from positive to negative, then definitely there must have been some zero, and that zero should arrive at, yes, this particular point, that is C. So for maxima point, if you say that x equal to C is a point of maxima, then definitely f dash c must be equal to 0. That is for sure. Okay, in this particular definition. And similarly, can you notice that if we are talking about x equal to c as a point of minima, right? So then what is happening? Yes, the slope at the left hand side LHS is negative. It is, you can see that the slant is negative, and the right hand side the slant is positive, right? So again there will be a 0 in between here, and that again happens at C point where the tangent is parallel to your x-axis, this particular stuff. Now why I am emphasizing more on this particular concept is, this is how you can actually remember. So whenever the slope of f dash x, let's say slope of f dash x changes from positive to negative, from left to right hand side, from positive to negative, this signifies point of maxima. Very important definition. And whenever you have that the slope of f dash x changes from negative to positive, from left to right hand side, this signifies point of minima. Very important definition. So you can actually tell me whether it's a point of maxima or minima by doing this particular activity by using f dash x. Okay, I'll explain this when we talk about the methods of finding maxima and minima. Okay, before we go on and start solving questions, a very important concept again, and we'll talk about here extreme points, and we'll also talk about something called critical points, right? So what do you understand by critical points? First of all, we'll talk about critical points, very important definition. So critical points are those points where first f dash x is equal to 0, that is roots of f dash x are critical points, or f dash x is not defined. In both these cases they are the critical point, is not defined, right? So I'll explain you with the help of the diagram that I have taken on my page. So for example, here you can see that at this particular point the slope is parallel to x-axis, so this is a critical point. Then C2 is also a critical point. Now let's talk about C3. By the diagram we can say that this is the point of local maximum, no problems. But can you tell me whether the derivative exists or not this point? No, at this point derivative does not exist, right? Derivative does not exist. Why? Because it is not a smooth edge here, it is a pointed edge. Whenever you have a pointed edge, that means it is not differentiable at this particular point. So derivative does not exist. Similarly, if you see here at C4, the same property, that the derivative does not exist, though it is still a point of local minima. So here what I have to say is that C1, C2, C3 and C4 are my critical points. Okay, and only C1 and C2 have differentiable points, or in fact not have, it should be are differentiable points, because you will not find the derivative at C3 and C4 because it does not exist. To differentiate between critical points and the extreme points, so extreme points are actually points where you will get, extreme points are the points where you will definitely get local maximum or local minimum values, local maximum or minimum value. Okay, but for a critical point you may or may not get a local maximum or local minimum even if these two conditions are satisfied. So this is the basic difference. So whenever extreme point is given, that A and B is the extreme point, let's say if for example in the question it is given A and B are extreme points, then you can say for sure that they are either maxima or minima, or they will fall in either of these two categories. But when an extreme point is given, it might be not be necessary that it will always be a point of maxima or minima. This is the basic difference. All right, so now let's move on to find the method of finding extreme points, that is points of maxima and minima. So the first method of finding the extreme points or the points of maxima and minima is the first derivative test. As the name suggests, what you people have to do is, here is, let's just we start with the step process, right? And you are given y is equal to fx as the function is given to you already. Okay, so what you people will do, find f dash x, find f dash x and equate it to 0, and equate it to 0, right? Second step would be to find solution. So find roots of f dash x, find roots of f dash x, right? Okay, find roots of f dash x and points where f dash x does not exist and where f dash x does not exist. Okay, this might be also there as we see in the diagram above. Okay, and the third would be check the sign change of f dash x, check sign change about these roots, check sign change of f dash x about these points. This is the first law or the first derivative test about these points. So for example, if you say that the roots of f dash x, roots of f dash x that you people will get are, let's say x is equal to a, b and c, right? So what you people will have to check in this one is that you will have to see that what is the value or the sign of f dash x, let's say at x equal to a I am talking about. So if it is from going from negative to positive, that is from left hand side you are traveling, remember you have to travel from the left hand side. If you travel from left hand side and you see the sign change from negative to positive, so remember when this happens, just remember the downward parabola. So downward parabola, here you can say the slope is negative and then here positive, and the slope on the right hand side is negative, whereas in the upward parabola slope here is negative and slope here is positive. So if it is going from negative to positive, that means this particular case, and this is the point of, yes, this is the point of minima, so a will become the point of minima. Okay, and let's say if b is there, it goes from positive to negative in this case, so positive to negative, then this point becomes point of maxima. And let's say if c is a point, you find that it is not changing the sign, so it was negative at the left side and also negative on the right side, so then we will say it is not a point of maxima or minima, it is not a point of maxima or minima, whatever you want to say about this. This is how you have to remember. This is the first derivative test. That means the most important point in the first derivative test is that you have to check sign change of f dash x. This is the most important part. I hope this is clear now. Okay, so just remember the concept using upward parabola and the downward parabola. So if the sign change, I just write the formula if the sign change happens in this format, that from negative to positive, right? So what you people will remember that this is point of minima. If it is going from positive to negative, it will be point of maxima, and you have to travel from LHS to RHS. You have to remember this, okay, while seeing for this signs. Let's take the other rule. So other rule is the second derivative test. So which is completely almost similar, that the first two steps are equal, that find f dash x, equate it to be 0, equate to 0, equate equal to 0, find roots, right? Find roots here. And the third step is now, rather than checking the sign, what we will do here, we will find f double dash x. And the fourth step will be to check for sign of f dash x at roots of f dash x, right? So that means if say you have taken here roots as x equal to a, b and c, you need to find what is the value at x equal to a, double derivative at x equal to b, double derivative at x equal to c. So if it comes out to be less than 0, so if double derivative comes out to be less than 0, yes, you know it very well that it will be point of maxima. If it comes out to be greater than 0, then it will be point of minima. Alright, clear? And if this comes out to be 0, then we will talk about, just do not worry about, we'll talk about a bit just right now after this slide, that what will happen if this comes out to be the case. Okay, got it? So this is actually the step, this is second method which actually is being followed at boards level. So if you are solving for board, then you will have to follow this. In fact, this is the problem method which you use in word problems very extensively, that you find f dash x, you find its roots, right? And then you find the value of the double derivative at their roots. For negative it is maxima, for positive it is minima, the opposite. This is how you can learn it. Okay, now let's see what happens when your double derivative comes out to be 0. Yes, this is now called point of inflection. So let me take a very basic diagram for you people to just understand the concept of point of inflection. So I have drawn the diagram of y equal to x cube here. This is y equal to x cube. Okay, now let's start with the step process that we have done. So I have taken y is equal to fx is equal to x cube. So what is the f dash x? F dash x is 3x square, right? And if I talk about the roots, so roots are, yes, there is only one root, that is x equal to 0. But never say anything when you find the root. So I do not know whether this x equal to 0 is a point of maxima or minima. I cannot say. So now let's see by first derivative and the second derivative. Both ways we will see. So first derivative test, right? First derivative test. So first derivative test was that you have to check for the value sign of f dash x about this root. So if I see that what is the sign, and also keep in mind that you have to check for sign of f dash x, not sign of fx. So sign of f dash x. So if you put a value which is less than 0, that is negative. So what will be the value of f dash x? And we are just interested in sign, not the value. Yes, it will be positive. And right hand side, obviously it is positive. So is there a sign change happening from left to right? So there is no sign change. There is no sign change that is happening. Okay, so that means this is having no max, this is not a point of maxima or minima. This is not a point of maxima or minima, as simple as that. Let's talk about the second derivative test. So for second derivative, what you will do, you will find f double dash x. So f double dash x is nothing but 6x, and then you were supposed to find f double dash at the roots of f dash x, that is x equal to 0, and interestingly this comes out to be 0, right? In fact, what we were expecting here, we were expecting either the value of 0 to become out less than or greater than 0. For this would be maxima, and if this would have been the case, then the answer would have been minima. But it comes out to be equal to 0. Then what to do? So then what we do, we again differentiate, let's say. So the third derivative in this case will be 6, right, which is non-zero. Okay, so if this happens in the case, let's say you find f dash x equal to 0, Now I am writing the rule of point of inflection. Listen to it very carefully, though it's not in the CBSE syllabus, but still some examinations might ask it. And we are not in fact doing it in a greater depth. People who are preparing for advanced, there is a lot more to be taught than about this particular step and what we have just learnt earlier, but we are just restricting ourselves to the basics of everything. Okay, so if you do the first step, that f dash x equal to 0, and you find the root as x equal to alpha. Okay, so that means f dash alpha is equal to 0. Then you find what? Second derivative, and you find that at x equal to alpha, second derivative is also 0. But then you find that at third derivative, the value at alpha is non-zero, right? This is the condition that x equal to a is point of inflection. Very important. So this is what is meant by point of inflection. So for point of inflection, what you people have to remember, f dash alpha equal to 0, f double dash alpha will be 0, but yes, f triple dash alpha will not be equal to 0. And mind it, this is just the basic definition, right? There are other rules also which I am not going to cover. This is the basic definition, right? So we could have done higher order derivative test also, but if you have done it and if you are not able to apply it, leave it. Believe me, JEE Mains will not ask more than this. That's the beauty. Okay, and what is the physical geometrical significance? What is the geometrical significance? So it is first of all not a turning point. Okay, as in the case of maxima and minima where the graph was turning, it will not turn. So what happens here is at the point of inflection, that is x equal to 0, you have determined x equal to 0 is a point of inflection. Why? Because the third derivative, so if you say that third derivative at 0 comes out to be 6, which is not equal to 0, that implies x equal to 0 is a point of inflection. The shape of the curve changes. So physical significance is the shape. It changes the shape of the curve. So for example, here it was concave downwards. It was concave downward because the cusp is moving towards its cusp is downward, right? And here the cusp is upward. So this is concave upward. So this is actually the physical significance or the geometrical significance of point of inflection, that your shape of the curve will actually change. It will be concave downward or concave upward or vice versa. I hope this point is clear. No need to get into more depth than what I have taught in these 10 minutes for JEE Mains and other entrance examinations. We will cover this in great depth when we talk about the advanced stuff, but not for now. Okay, now let's take a very basic question to first of all start with the question front, because we have been doing theory for a long time. It says if fx is equal to this has no extreme values, right? So no extreme values. So this means no maxima nor any minima, right? So this is the particular thing that is given to you in the question, and then you have to prove a relation between P and Q. So for any, it does not have any maxima and minima. So what is how we find maximum and minima? We first of all we find f dash x. So f dash x is 3x square plus 2px plus q, right? And can you see that this is completely a quadratic equation, and quadratic must have two roots, and if these two roots comes out to be real, right? If these two roots are real, then we will have what? Maxima and minima. If these are real, that implies we will have maxima and minima in place. But you are asked that there are no maxima and minima. So that means this quadratic should not have any real roots. That means this quadratic should not have any real root. Then only we can say that there will be no point of maxima or minima, and this you can easily solve by putting d less than equal to 0, because that is the condition when quadratic does not have any real root. So this becomes what? 4p square minus 4 into 3 into q should be less than 0. If you solve, this becomes p square minus 3q less than 0, and if you check, this is what is being asked of you. This is the answer, or hence proved, right? So very basic problem. It was just taken so that you can understand the concept that what do you mean by extreme value. Got it? Okay, Before we go further, let's take the concept of global or the absolute maximum or minimum. So if I say that in books you will also find maximum or minimum over closed interval, right? This is also one of the topics which you can find in this way, over closed interval. So for example, the diagram that is there on the screen is y is equal to fx when x belongs to closed brackets a to b, right? So let me call this point as a comma fa and this point over here as b comma fb, right? Okay, so you need to find the global. So what do you mean by global maximum value? Global max, as the name suggests, global, that is the largest value in the domain, largest value in the domain. Okay, this is what is meant by global or the absolute value. Okay, so if you see, I denote this particular point as C and let's say I denote this point as D. So you can see that D is a point of maxima, but it is not absolute maxima, it is a point of local maxima. Similarly, C here is a point of, though it is a global minimum, it is also a point of local minimum. Again, there is another point E, let's see here, right? So it is also a point of local minimum, right? So here you are getting three values, that is, let me write, at C, D and E you have extreme points. They are actually what? They are extreme points because you are obtaining local maximum minimum values. But now if we talk about the global maximum or global minimum value, so it is not necessary that local maximum would be the greatest value or local minimum will be the lowest value. So for example, here there are two local minimums, right? There are two local minimum if I talk about, that is C and E, and out of this we know that C is less than E and C is the smallest value, C is the smallest value of fx, right? If we talk about in this particular domain. So that is why I have attributed it to be global minimum. Whereas if I see there is only one local maximum, right? There is only one local maximum, that is D, but I am not calling this straight away as global maximum. Understand this way. So it is not necessary that the local maximum will always be the global maximum. Now for global maximum or minimum, what you have to remember is, the rule says for global maximum what we will use is the maximum function. Very simple, I explain you. So what you will do, will find the value at the extreme point, that is this A, B and values at extreme points, right? At extreme points. So that is what I am asking is, you will try and find maximum of FA, FB, C, D and E, right? This is what you need to find. In fact, you can skip the local minimum in that case, but still we write. So this is nothing but this is maximum function. Don't get depressed by what it is. It is very simple, that you need to find the maximum among these five values. So if you go about in the diagram, you will see that the maximum value is at this particular point. So this point is actually the global maximum. The answer to this answer will be FA. And similarly, if I talk about the global minimum, this will be replaced by minimum of FA, FB and the values at the extreme points. And if you see now, so you will actually check five values here, two of the extreme points and three of the two of the boundary points and three of the extreme points, and out of these the maximum value will be the global maximum and the minimum value out of these five will be the global minimum. So if you compare these five particular points, let's say this is A, this was your B point, so A is the highest value and yes, C is the lowest on the graph. So that is why I am calling this as global minimum, and this is the concept of global maximum and global minimum. Let's take a question on the concept of global maximum and minimum. You are asked to find the greatest value of the function x cube minus 12x square plus 45x when x ranges from 0 to 7, right? This is what is we need to find. So let's first of all start with the process of finding extreme points. That is, you will differentiate, and if you differentiate, this is what you people will get, right? And if you equate it to 0, so this quadratic will be revealed, and this quadratic can be easily solved because the answer to this particular quadratic will be x equal to 3 and 5. So here are your extreme points, right? And if I have to completely explain you, and if we were to try and find which one of them will be the maximum or the minimum value, so just draw a wavy curve the way we used to draw. So plot them on the number line. Remember, if this is a polynomial, then you can directly apply the wavy curve method. So what was wavy curve method? That positive, negative, positive. So positive will be placed on the right hand side, then sign change, and then sign change, right? This is just we are solving inequalities. This is the process of solving inequalities. But this is only valid for polynomials. You should not apply this in the trigonometry part. Or you can just go about what board people or the school teacher must have told you by drawing tables or whatever you want to find. So that means the sign here for 3 is changing from positive to negative. When this happens, yes, so 3 is a point of maxima and 5 is a point of minima, right? So this is point of maxima and this will be a point of minima. By seeing the sign change, we can say so. Okay, so now you have extreme points as, and in fact we have also found out which is the maxima. So we know that maxima is x is equal to 3, and we know that the minima is nothing but x equal to 5. So we know these facts. So now we were asked greatest value, right? Or greatest means the global maxima or the global minima. So we want to find the global maximum value. So now what you will do is you will say maximum of either f3 or f5. Though in fact in most of the cases I should not write f5 because this is a point of minima, right? I should only compare it with the maxima part. Okay, so I can actually leave this from here. Okay, and then don't you just have to find f3, you will also check at the boundary point, that is f0 and yes, f7 also. This is what I wanted to explain it to you. So if we find all these values, so let's say we find f3. What is f3? Can you tell me very quickly? So these 4 particular values will be obtained if we talk about these 4 points. Can you tell me what is the global maximum value then? Notice the global maximum value is being obtained at f7. So the maximum output or the maximum value in this particular range or domain is nothing but 70. This is your answer. And this is being obtained as a boundary point, that is at x equal to 7 you are getting this answer. So have it been the case that I would have asked what is the global minimum value, what answer would you have given to me? What would have been the global minimum value? Out of these four, what is the global minimum? Again you see that is coming at the 0. So global minimum value is at x equal to 0, that is f0, that is equal to 0. Then the answer would have been this particular answer. Okay. Note in both these cases, that is global maximum value and global minimum value, we are not getting answers of local maxima or local minima. We are getting answers at the boundary points. Okay, now let's take the question. It says if the minimum value of this particular function a times square x plus b cot square x equals the maximum value of the other function where a and b are given in this relation that both are positive and a is greater than b, then you have to prove that a will be nothing but equal to 4b. Okay, let's see how we will do this first of all. So it is, let's say a function that is given to you is fx a tan square x plus b cot square x, right? This is given to you, and it is said that the minimum value of this particular function is equal to the maximum value of the other function, right? Maximum value of this other function which is in terms of a, b and theta, right? Clear? So let's first of all find the minimum value of this function. Okay, so how you will find minimum value of this function? Now, why I have taken this particular problem, that whenever we see maxima minima, we straight away start differentiating that particular quantity, and this is what is generally not asked at the engineering exams. So I'll show you how. There is a common pattern over here. If you can tell me what will be the pattern. So tan and cot are, yes, reciprocals of each other, absolutely. So can I form a complete square over here? What I can say, let's see, if I say root a tan x, right, minus root b cot x whole square. So what this value would be? This will be a tan square x plus b cot square x. This is what you people have, and it will have a term. What extra term this will have? Minus 2 root a root b into tan x into cot x, and obviously this will cancel out, and this is the extra term. And if I add 2 root ab, then I can say this and this particular values are equal. Got it? So now let me just remove this particular stuff here. Okay, so now if you tell me that this is your particular function, which is something square plus 2 root ab, and a and b are both positive, can you tell me what will be the minimum value? What could be the minimum value of a square? Yes, this could be 0. So the minimum value of fx, is nothing but, yes, 2 root ab. Straight away we got the answer. If you had tried to go on by the derivative approach, it would have become a bit lengthy. It is completely straight away. So figure out the pattern wherever there is a 1 in the question available. So now we know that the maximum value of this particular quantity is nothing but 2 root ab. Okay, so now let's take this function as g theta, which is a sine square theta plus b cos square theta. Now can I form a pattern again over here? It is difficult now because they are not reciprocal pairs of each other, because you will here, if you see, this particular component was constant, right? And this particular component was a variable, but it was in the square, so minimum value we could have said that it is equal to 0. But here if you will do something of 2ab minus 2ab, you will again get both of them variables, which will not help our case. Now let's say if we differentiate this one, so what value you will get? It will be 2a sin theta cos theta, and this will be what? Minus 2b sin theta cos theta, right? And if you see, if I combine, this can become a minus b sin 2 theta, right? And you need to find the maximum value. So maximum value will be occurring at the root of this. So if we find the root, that means this could be 0 because a minus b is not 0. So that means this 2 theta is equal to 0, or it could be equal to pi, right? This could be the answer. And if we say that theta is equal to 0, then does it make sense? We'll see it. So let's say if theta is equal to 0 or pi by 2. So let's say we are just taking these two extreme points. These are the two extreme points. Now we want to check at which one of these you will get the maximum value, because you need to find the maximum value. So let's double differentiate this. You get g double dash theta as, well, now it's a very simple function. We can very easily differentiate. This will become 2 times a minus b cos 2 theta. What is g double dash theta at 0? We want to find g double dash theta at x equal to 0, let's say. So this will be 2 times a minus b, right? And let's say what will be the value when we say g dash pi by 2. Sorry, yes, pi by 2. Now tell me what will be the value. So this value will be nothing but negative of this particular value. Now let me ask you, which one of them is for maximum? What you will get? Double derivative should be negative. So let's see the sign of the double derivative. It is given that a is greater than b, so that means this is positive, and this quantity will become negative. And you want for, so if I just start solving here, so for maximum, yes, we need that the double derivative at alpha should be less than 0, and this is happening for x is equal to, or let's say theta is equal to pi by 2. So theta is equal to pi by 2 will give you the maximum value of g theta function. Just compare it, what it will become. So maximum value will be what? When you put theta is equal to pi by 2 over here. If you put pi by 2, it will be nothing but a, right? So you want to compare this now with 2ab. It is given to that the maximum value is equal to the minimum value of this, and we have found minimum value is nothing but this particular answer. Just simply square and we will found our answer, right? So this is nothing but a is equal to 4b, hence proof. This is the answer we were looking for, and this is how you will solve questions similar to this pattern. Now let's take the next problem. Here you want to find the greatest value of the function, which is something like x plus 1 raised to power 1 by 3 minus of x minus 1 raised to power 1 by 3. Okay, so for greatest, again we will start with finding the derivatives. So if we start with the derivative, what will be the derivative? Yes, so x plus 1 raised to power 2 by 3, and this will be what? Minus 1 by 3 x minus 1 raised to power 2 by 3. Okay, and if you try and simplify, what you will need to find here is that you will be requiring to solve this particular stuff. We'll come to this, but first of all, let's see what is happening. So I have done a mistake here. Can you tell me what is the mistake? Yes. So this is minus 2 by 3. This is what we do. Commonly we do this error. So if we see this, so 1 by 3 if I take common, so this should something look like this, because this will now come in denominator and this will also come in denominator. Okay, now can you tell me what values of x are there for which f dash x is not defined? Can you tell me? Yes, so x equal to plus minus 1, at x equal to plus minus 1, f dash x is not defined. Why? Because you can say it is in the denominator, so it will not be defined. Okay, so we'll talk about this because this is also our critical point, as I told you in the earlier concept, that it is also critical point where f dash x is not defined. So now if we have to solve that f dash x equal to 0, so what this particular quantity will become, that f dash x is equal to 1 by 3 times x minus 1 raised to power 2 by 3 minus of x plus 1 raised to power 2 by 3 divided by x plus 1 2 by 3 and x minus 1 raised to power 2 by 3. So if this has to be equal to 0, that means the numerator should be 0. You can say x minus 1 raised to power 2 by 3 is equal to x plus 1 raised to power 2 by 3. So how do you solve this particular problem now? Is that if you immediately do this, that you cancel the power, what you will get is something of this sort, which is never true. Whereas this has to be solved something like this. So if I say, if you cube both sides, so this is what you will get, right? Cubing, I can say I have cubing both sides. Okay, so a square is equal to b square. Let's say understand it this way, a square is equal to b square, so that what you will say, a is equal to plus minus b. So this is just one component, that you will say a is equal to b, then x minus a is equal to x plus 1. No problem, you do not get the answer, but this could have also been true if this was the case, right? And if you solve this, what it will become? It will become 2x equal to 0. So this implies x equal to 0 is the point which we were all trying to find. So this is the point that we were all looking for. So now we have 3 critical points, right? So 3 critical CPs. So x is equal to 0 and x is equal to plus minus 1. So these are the 3 critical points that we have obtained till yet. Now we need to find the greatest value that will be obtained. Okay. So out of these three, we know that x equal to 0, right, is a point of maxima or minima, right? Because f dash x equal to 0 is coming out. Now, can we check whether this is a point of maxima or minima? By just orally doing it, we need to find the change of sign of f dash x about 0. Can you tell me how you can do orally without going to double derivative? Because double derivative is a lengthy approach, remember, right? So if you just see that this is the numerator of f double dash of f dash x, and this is the denominator. So denominator is completely a positive quantity, because here you are having power 2 by 3. To power 2 by 3 will make everything positive, because of 2 square you will do square and then you will take cube root and they are multiplied, right? So this is positive, denominator is positive. Whatever will come from the sign will be only for the numerator, will give you the sign. Now how we'll find the sign? So let's say if I am coming from the left hand side of 0, that means it will be a negative fraction. So this will become what? Minus something, minus 1. So this number eventually inside will be a number greater than minus or less than minus 1, and when you square it will be a number greater than 1. Got it? Now let's say if I put negative over here, so this will be a number less than 1. Obviously here it is a number less than 1, here is a number greater than 1. Its cube root will be greater, its cube root will be smaller, so you will have plus sign here. And if you apply the same concept here, it will be a negative sign on the right hand side, and you are going from positive to negative. That means this is a point of maxima or minima? Yes, it's a point of maxima, as simple as that. Okay, so this is how you have to solve in engineering entrance examinations, where you can solve it very quickly. So we know that this is a point of maxima. So now just quickly solve what is f0. If you just put f0, what is coming out? This is 1. This will be minus 1 raised to power 1 by 3. That will be again 1. So minus 1, minus 1, minus 1. Yes, it will come out to be 2. Now tell me what are the values at the other extreme points, that is f1 and f minus 1. Though we need not calculate f minus 1 because the range or the domain of x is given to us is 0 to 1. But still, let's see. First of all, let's find out f1. What you will say to f1? This will become 0. This will be 2 raised to power 1 by 3, right? And if I talk about minus 1, so this will be 0 here, and it will become what? Again 2 raised to power 1 by 3. Okay, if we were asked to. So if you were asked the greatest value, so what answer you would get? And in fact, if you were to ask in this particular domain, so at f0 you are getting 2, that is the maximum, and at the boundary point you are getting 2 raised to power 1 by 3, and the other boundary point is itself 0, right? So at x equal to 0, it is actually that boundary point and the global maxima has coincide. So the global maximum value is nothing but 2 only, right? This is how you solve these kind of questions. Now let's take a problem which was already asked at AIEEE, and it's a beautiful problem to understand the basic concepts of maxima and minima. So px is a biquadratic function that is given to you. Px is x raised to power 4 plus ax cube plus bx square plus cx plus d. This is given, and this is given such that x equal to 0 is the only real root, very important stuff, the only real root of p dash x, and it is given that p of minus 1 is smaller than p1. Then you were asked to find whether p minus 1 is minimum or p1 is maximum or not, and vice versa. Just go through the questions first of all. Okay, the option, sorry. So if you are given that only real root of p dash x, so p dash x is involved. Let's say we find p dash x. So p dash x is 4x cube plus 3ax square plus 2bx plus c, and you are given that p dash 0 is equal to 0. So from here you can easily see that c is equal to 0, right? So if c is equal to 0, so then if I rechange my question, so this becomes p dash x is nothing but 4x cube plus 3a x square plus 2bx, and if I take x common from here, what you will get? 4x square plus 3ax plus 2b, right? And for this particular quadratic, we know that d would be less than 0. Why? Because it will have no other solution, because it is clearly given that p dash x has only one particular root. Okay, and since this has only one particular root, so that means there is only one critical point. There is only one critical point. What is that point now? So one critical point is only x is equal to 0 in this particular case. Okay, just add one more stuff here, that then in -1 to 1 this was the equation, right? It is not for x belonging to R, so then that will be wrong. So here the range of x or the domain of x is given to be this. Now carrying on with our particular question, so you have got critical point x equal to 0. Now you want to find out what this point is all about, either it's a maxima or a minima. So for that we'll do double derivative. So double derivative of p dash x will be nothing but 12x square plus 6ax plus 2b, and what will be the value at 0? Then p double dash 0 is nothing but 2b. Now everything depends on 2b. If this comes out to be positive, then this will be point of minima, and this comes out to be negative, then this point will be minima. Now how do we figure out what is the value of b, positive or negative? Now we also had here that d is less than 0. So what is d less than 0? Let's calculate. D is b square minus 4ac. So this becomes 9a square minus 4 into 4 into 2b, and this should be less than 0, right? So can you say something that it becomes 9a square less than 1632b, or I can say b is greater than 9a square by 32. And now if you compare for this particular inequality, that this RHS is completely positive, because a square will be positive, 9 positive, 32 positive. So can I say here easily that b is also positive, b is greater than 0 from this particular case? And so if b is positive, so that means this is also positive, so that implies x equal to 0 then is a point of yes, maxima or minima? Positive, yes, it's a point of minima then, right? So we have got till now that of this particular px, x equal to 0 is the point of minima. That is what we can say very easily. And since we only have one critical point, that means there is no other local minimum involved. So I can say that the global minimum here in this particular global minimum in -1 to 1 will be nothing but at x equal to 0. That's for sure, right? Clearly. So in fact I can say that any of these 2 points, that is p-1 and p1, is not minimum, because minimum will be obtained at, so minimum is nothing but p0. That's for sure. This is what we have obtained till now. Okay, now we need to figure out what is maximum value. Now it is already given in the question. So it is said that for global maximum, what you people would have done, remember, for global maximum we used to do maximum of fa, fb and the values at the extreme point. But since there is no global maximum available, so you will just take the maximum of the boundary points. And what is the maximum? Yes, p1. So answer would be p1. So just match your answer that p-1 is not minimum, but p1 is the maximum. B is the answer that we were looking for. Okay, if I want to elaborate on this, and if you are not able to understand by this, let me take a detailed version of this. So it's, let's say p dash x. So you know p dash x here, I'm just carrying forward that p dash x is equal to x into a quadratic. Now this quadratic is always positive. Can you tell me why? Yes, I will. So here d is less than 0 and the coefficient of x square is positive. So if the coefficient of x square is positive and d is less than 0, quadratic is always positive. So that means if I have to draw its wavy curve 0, so this is the sign. So that means p dash x is positive in this particular region and p dash x is negative in this particular region. This implies px is increasing for x greater than 0 and it is decreasing for x less than 0. I can also say in this way. So if it is increasing, that means if I talk about x greater than 0, So x equal to 0 will be minimum and x equal to 1 will be maximum. If I talk about x less than 0, now minimum will be obtained at, yes, -1 and the maximum will be obtained at 0. So here I am writing the minimum values and here I am writing the max component. So if it is decreasing, so at decreasing, what will be the answer? You will get minimum value at minimum value, sorry, so I just have to replace this because I'll rewrite this for you people. Yeah, just quickly, so p dash x I have got that is increasing for x greater than 0 and decreasing for x less than 0. And if I have to explain minimum and maximum, let's say, so for x greater than 0, minimum will be obtained at x equal to 0 and maximum will be obtained at x equal to 1. For x less than 0, since it is a decreasing graph, so as decreasing mean as the value of x increases, yes, the value decreases, right? So where the minimum value will be obtained? Again it will be obtained at 0 and the maximum will be obtained at -1, right? So you can easily see that minimum is for sure at x equal to 0. The only problem is with the maximum. So either the maximum value will be obtained at 1 or will be obtained at -1, and we are given that p of 1 is greater than -1, so p1 is the answer. I hope this question is now pretty much clear. Now this question is that p is given to be x cube minus 1 by x cube and q is given to be x minus 1 by x for x greater than 0, right? This is given to you. Now you are asked to find minimum value of, min value of p by q square. Okay, so immediately do not start solving p by q square first of all. So in fact these kind of questions are very much which could be asked in your entrance examinations. Why? I'll tell you now. So can you see again a pattern here? Is there a pattern which you people can tell me? Pattern is that p can be expressed in terms of y. P can be expressed in terms of q. How now? Let's see. So p is x cube minus 1 by x cube. Can you write this for me in terms of q? Okay, so for this we will do the formula. What is the formula of a cube a minus b whole cube? Tell me. It is a cube minus b cube minus 3ab a minus b. This is the formula that you people use generally. And if I just ask you a cube minus b cube, then it will be a minus b whole cube plus 3ab a minus b. You can tell me this. Now just apply this over here. So p can be written as, this is a cube minus b cube. This will become what? X minus 1 by x cube plus 3ab. So 3ab will be, yes, it will be 1. So only 3, and a minus b, that is x minus, or you can say p is nothing but cube into 3 cube. Very simple, right? And now you are asked to find the maximum or the minimum value of p by q square. So p by q square will be q plus 3 by q. Can you say this? Okay, now you want to find minimum, so you want to differentiate this. So I'll assume this particular function, let's say at z. So you want dz by dx. Let me solve it quickly and I'll show you how it could be done. So I can say dq by dx for this. This will be what? Minus 3 by q square into dq by dx. And if you take dq by dx common, right, dq by dx common, it will be 1 minus 3 by q square, right? What is dq by dx for that matter? So dq by dx is nothing but you differentiate this particular thing and this will come out to be 1 plus 1 by x square, and this is always positive because 1 upon 1 plus x square is positive, and if you say this is equal to 0, So the 0 should come out from this particular bracket because dq by dx is always a positive quantity. This becomes this sort of thing. And if you solve this completely, I am now solving it over here. So it will be what? Q square is equal to what? Yes, q square equal to 3, and you can say q is equal to plus minus root 3 are the critical points. Okay. So if you draw the wavy curve, so let's say I'll again say that what is dz by dx, you have dq by dx, and if I take the LCM, it will be q square minus 3 by q square, right? So what the critical points would be, the sign of this particular quantity is only dependent on the numerator, that is q square minus 3, and if I draw this on the wavy curve, so it will be minus root 3, this will be plus, minus and plus. Yes, you can easily see that the minimum value of q will be obtained at, so minimum is at q equal to root 3, right? So just simply replace the value here to find the answer. So the minimum value of z is nothing but what you can say, so z min is equal to root 3 plus 3 by root 3, or basically I can say 2 root 3. So this is how you solve this particular question. In fact, if you see, the best part about this particular question is that we have solved the question entirely in Q. We have not got involved in X. We have solved the entire question in Q, and that is why I would say that this is a very good question to understand how you can solve question based on pattern based, something of this sort. If you have tried to solve this in X, this question would have become really very lengthy. Okay, so for this particular question, which says fx is equal to integral of 0 to x e raised to power t square t minus 2 into t minus 3, where x ranges from 0 to infinity. You want to prove that it has local maximum at 2 and local minimum at x equal to 3. So why I have taken this problem, though in fact we will do this in definite integration, this is because we need to know Leibniz rule of differentiation, for integration. So that is that you need to find derivative of an integral. How you solve this? So what formula you people should remember actually? So the formula is that if fx is equal to 0 to x, and here inside there is some other function, let's say gt, and it is getting integrated with respect to t. So what f dash x would be is nothing but that you change this x over here inside g, that is gx. As simple as that. Okay, I'll do the elongated formula of this in definite integration when we start this, but for mains level this is what is actually required, and this is something really very important. So derivative is nothing but of this integral is that you replace this x here and forget about everything. This is the basic, this is most basic step that we can do for this particular formula, a completely basic formula. Okay, now let us see how we solve this question when we know this formula. So if you just do f dash x, so whatever is this is complete gx now. So what this will become? E raised to power x square into x minus 2 into x minus 3. And if we start solving this as equate this to 0, so e raised to power x square will never be equal to 0. So the two critical points that you will obtain will be, yes, 2 and 3 over here. And if you want to find which one of them is maxima or minima, then again draw on the scale number line. This is always positive. So now I have f dash x as e raised to power x square x minus 2 into x minus 3. This quantity is always positive, right? Always positive. So if I try and solve it, so let's say for greater than 0, so you will be only solving this here, right? And if you want to solve this, what will happen? Plus, minus, plus. That is wavy curve method, right? Wavy curve method of wavy curve method for inequality. So here f dash x is positive, this means here f dash x is negative, and in this region f dash x is positive. So again see the sign change. So above 2 it is going from positive to negative, so this means it is maximum. So this is the point of maxima, and negative to positive, then this becomes a point of minima. Very normal. Now the main target of this particular question was to explain to you people the Leibniz rule of differentiation. I hope this is clear now. Okay, now let's apply the concept of maxima and minima in geometrical problem. It says if C lies between 0 to 5, then find the minimum distance of point 0 to 0 comma C from the parabola y equal to x square. So you have a parabola y equal to x square, and you have to find the minimum distance of this parabola from the point 0 comma C. So now let me take any parametric point on the parabola as, let's say I take it at root t comma t. I'll tell you why I'm taking this. You will yourself see, because by this the calculation becomes very easy. So any point on this can be taken as root t comma t, right? And let's say I say this is the C point, so you need the PC distance to be minimum, right? So how do you solve geometrical or world problems is that PC distance to be minimum. Here what is the variable? C is constant, because why? It is given in the question itself. What is the parameter? So parameter is 1 here, that is parameter is t. So on this parameter you will differentiate and find maximum or minimum, whatever. So in this case, for example, we have to find the minimum, so we will find minimum based on this particular parameter. So now first of all let's try and find PC. So PC would be what? So the distance PC would be, let's say, under root of, now tell me the distance. So it will be root t minus 0 whole square, that is t, and t minus c square, right? And since PC is a distance, if you need to minimize p, you want PC minimum, right? It will be equivalent to saying that you find PC square minimum. That's not a problem, because if this distance is minimum, this distance will also be minimum. So let's say if I try and solve PC square, why? Because I'm doing this because the under root will get over then. Now you just need to minimize, let's say this is now new quantity x, you want to minimize PC square, which is something like this, right? And if you just solve this, this will come out to be what? T square plus this will be what? 1 minus 2c t plus c square. So this will be the quadratic that you will get in terms of t. Now just do the derivative. Differentiate this particular expression with respect to t. So this will be 2t plus 1 minus 2c, and just equate this to be 0. And since this is nothing but a quadratic, can you see this is a quadratic with the a greater than 0, so this implies this is a upward parabola. So in case of upward parabola, you will only get a point of minima, you will not have any other point. So no need of solving even for this, that when I say that t is 2c minus 1, so this is point of minima, obviously, right? No need to then satisfy these kind of things. So that means c is nothing but t in terms of c is nothing but c minus 1 by 2. So you need to just replace this value of t over here. That's it. So PC min is nothing but under root of t is nothing but c minus 1 by 2 plus this will be c minus, can you calculate this now for me? Yes, so it will be something 1 by 2 whole square, right? And this will be the under root part. So simply I can say this is nothing but c minus 1 by 4, and this is the answer we are looking for. Hence the B part is the option. So you can see that by doing some proper substitution, we can actually reduce the question by a huge level. Okay, and this is what you people should try and understand, and this is the difference from a board level problem when you solve it in a big lengthy way to a problem which you can solve in within 2 minutes, or when let's say 1.5 minutes at entrance examinations. Now let us take the other geometrical problem, and this problem is much more inclined towards the subjective part of it, which could be asked in your board examinations. Let's see how we'll solve this. So it says find the area of the greatest rectangle that can be inscribed in this particular ellipse. So first of all, what you have to understand in the geometry problem, it's a pure geometry problem. So in geometry, all the questions that are going to be asked of you will be highly symmetrical in nature, right? So I'll explain what is symmetry in this particular example. So ellipse is a complete symmetrical figure. So ellipse is symmetrical about x-axis and y-axis both. So what do you mean by symmetrical about x and y-axis? That the portion which is above x-axis will be equally below x-axis. The portion which is towards the right will be equally towards the left. So x and y-axis acts as a mirror. So whatever be the second particular thing which will be inside this rectangle will also be completely symmetrical about x-axis and y-axis. So that is why if you see, I have taken that if x is this distance of the rectangle, so this will also be x. So that means this will also be the center of the rectangle, and this will also be y. So then area of rectangle, what will it become here? So area of rectangle will be, you can say AB into BC, right? And AB is nothing but, yes, 2x, and this will be 2y. So you need to find 4xy. And there, since here there are two parameters x and y, we can differentiate with only respect to one. So we need to find x in terms of y or y in terms of x. For that, see here, what is the position of C? X comma y, because since this is x and this height is y, this point is x and y, and this x comma y satisfies this particular expression. So that means I can say x square by a square plus y square by b square equal to 1. So what is the value of y square in terms of x? It will be b square by a square times a square minus x square. Now if you take the under root, you can say that you will get the value of y, but you will get something of this sort, right? B by a under root a square minus x square. And if you substitute here, what your target is, let's say a, your a is 4xy, and you need to find something of dA by something, dA by dx. If I replace by y here, can you see that this will be a quantity which will be in heavily into under root, and it will take your time, right? Time consuming. So again, what I'll do, I'll rather than maximize a, I maximize a square, because if a square is maximum, then a will also be maximum. So what I will do is I'll maximize a square. Let's say I'll take it at z is equal to a square. So this becomes very easy, you see. So this becomes what? B square by a square into a square minus x square. And if you completely simplify, this becomes 16b square by a square x square minus x raised to power 4. And in fact, to be much more honest, let's suppose that I do not put this at z. Let us assume this as z. Why? Because this is a constant. The only parameter is this. So if I have to find the maximum, then the maximum should come from this particular quantity. Now let's differentiate this with respect to x to find the maximum. So what it will become? 2a square x minus 4 x cube equal to 0. This is how you solve derivative. So what values of x you can take it from? X first into what you can say 2x can be taken common. So this will become a square minus 2x square, right? And it will say x equal to 0, though this cannot be the answer. If x is equal to 0, that means you are not drawing any rectangle anyway, because the width will be 0, right? And this will give you two answers. X is equal to plus minus a by root 2. Now you need to find out for which value of x you will get the maximum value. So you have this particular value here. This is your first derivative, right? Differentiate it again to find the maxima and minima. So if I do something of d square z by dx square, so here this particular answer would look like 2a square minus 12x square, right? Something of this sort. Okay, and we do not want the negative value. So see here, you are getting x equal to minus a by root 2 also. Since we are talking about length, x was taken to be the length, I will not say that I'll take x equal to minus a by 2. So now I'll just check what is x equal to a by root 2. So substitute the value of x equal to a by root 2 in here. What value you will get? Yes, this will come out to be, can you see that it will come out to be a negative value? So negative value. So this means that this particular answer is maximum point. So this is the maximum that you will obtain, and since you have got the maximum value of x for which maximum area will be obtained, so what is the maximum area that you will find? So what is the maximum area now? Just replace this particular value over here, that is your answer over here. So that will be what? 16b square by a square, right, into x square. X square is nothing but a square by 2 into a square minus x square, that will again give you a square minus a square by 2, which will be again a square by 2. So if you calculate, this comes out to be what? Yes, 4a square b square, right? And if you answer that this is your answer and you mark this out, then this is wrong. Why? Now consider what we tried to solve was a square, not a. So you will again have to take the under root. So the answer to this particular problem then will be not 4a square ab, but yes, 2ab. So this is the answer we are looking for in this particular problem. And this is how you can actually simplify and reduce your calculation time by squaring, by taking only the parameters into the differentiation and all these kind of activities. Okay, I hope the problem is now clear to you. Now let's take other problem. It says an isosceles triangle of vertical angle 2 theta. So what do you mean by, first of all, vertical angle? So this particular stuff, angle A. So angle A is known as the vertical angle, right? This is the vertical angle. So vertical angle is given to be 2 theta, and by symmetry again I can say, so this will be splitted up in theta and theta, like this. It is inscribed in a circle of radius A. Radius is given. Show that the area of the triangle is maximum. So again here isosceles triangle is given to you, right? Isosceles triangle. So if I try and understand what is symmetry in terms of isosceles triangle, so if I draw AD be the perpendicular over here, right, this will bisect the base also, and it will also pass through the center of the circle, and this AD will divide the triangle into two equal parts, right? So ABD and ACD will have equal areas over here. Okay, so let's start by doing this particular stuff. You need to find area of triangle. You want to maximize area of triangle. So what will be the area of triangle? If I say that this is perpendicular, that will be half base into altitude. Base is BC and the height is nothing but AD. So now our target is to find it BC and AD. Now since this is circle and this is center, so the angle subtended by the chord at the circumference is half of the angle subtended at the center. So if this is 2 theta, this will completely be 4 theta, and this will actually become 2 theta, which I have already written on the screen, right? And the radius is given to be A, right? You know that fact. So if radius is A, let me call this point as O, right? What will be OD then? Can you tell me what will be OD? OD will be A cos 2 theta, right? Right, and similarly I can say that BD will be A sine 2 theta, right? So if OD is given to you, you can now find AD. What is AD? AD is AO plus OD. AO is nothing but radius, so this becomes A plus A cos 2 theta, right? And this particular BD, so now from this we can find BC. BC is nothing but 2 times BD. So this will become what? 2A sine 2 theta, right? So now you need to find area. Let's see what area will get boiled to. Area is half into 2A sine 2 theta into, if you take A common, it will be 1 plus cos 2 theta. Can you see that this now again completely becomes a trigonometry problem? If you see, this becomes A square sine 2 theta into 1 plus cos 2 theta, and you need to maximize this. So again, if I say that I take a variable z which is only in terms of its parameter, right? This is the parameter. So I can say this is sine 2 theta plus sine 2 theta and cos 2 theta, and this further can be reduced to sine 2 theta plus 1 by 2 sine 4 theta, sine 2a formula, right? So this is z. Now you want to maximize this z. Let's start differentiation then. dz by d theta will be what? 2 times cos 2 theta. This will be what? Plus 1 by 2 into 4 cos 4 theta, right? This is, and this will reduce to what? I can take 2 common and this will be cos 2 theta plus cos 4 theta. This is what you will get of dz by d theta. Now you wanted this to be equal to 0. So let's put this to be equal to 0. So you will get cos 2 theta plus cos 4 theta equal to 0. Now this is again a completely trigonometry question, right? And in fact this is trigonometric equation, if you remember, right? So this is trigonometric equation. Now how we will solve this is cos 2 theta is equal to minus cos 4 theta. In which quadrant cos is negative? Yes, the cos is negative in your second quadrant, so you can write this as cos pi minus 4 theta, right? And now if you remove the cos from both sides, you will get something of this sort, which is theta is equal to pi by 6. So this is one of your extreme points, one extreme point. Now check whether this point is of maxima or minima, and if you compare, you actually wanted theta to come out to be pi by 6. So you have actually got till the right step. Now the only step left is to prove that this is for maxima. So for maxima, what you will do, you will differentiate this once again and prove that this is yes. So what is d square z by d theta square? So this will be what? 2 times minus sine 2 theta, right? Minus 4 sine 4 theta. This will be the second derivative. And if you put theta is equal to pi by 6 over here, obviously what value you will get? Yes, you will get a negative value. For negative value, that means this is nothing but maxima, and hence prove. This is what you wanted to prove. Okay, so again we have applied symmetry in this particular problem. This is how you will actually solve this particular problem if it comes in the paper. Again, I have tried to apply the symmetry and reduce the component of solving in this particular question. Now let's take another problem which is much more relevant towards your entrance examination. It says a curve whose slope is x square minus 2x passes through the point this. Find the point with the greatest ordinate on the curve. So now what is given to you is dy by dx is now given to you. A curve whose slope at x and x comma y is this. So slope is nothing but dy by dx. We did it in tangent and so normal, right? This is now given. Now you want to find the curve first of all. Your target is to figure out what is the value of y. Then only you can find its maximum value, na? So what you will do? Yes, integrate this. So if you integrate, what you will do? Something of this sort, x square minus 2x dx, and then you will say integral. So this will be what? Y is equal to x cube by 3 minus x square plus constant of integration. Now how do you remove this constant of integration? For this it is given that this curve passes through 2 comma 0. Now you understand why that 2 comma 0 is given. So 2 comma 0 should satisfy. So this is nothing but what it will become, 8 by 3 minus 4 plus c, right? And if you solve this, c comes out to be nothing but, yes, 4 by 3. So now you have actually got your question. Now this becomes a very simple problem. Now you have got your y equal to fx, that is x cube by 3 minus x square, and this becomes plus 4 by 3. Now you want to maximize y. You want to maximize y to differentiate dy by dx again. So if you do dy by dx, you know what you will get. You will get x square minus 2x, right? And if you equate it to be equal to 0, you will get two particular answers, that is 0 and 2. Since it's polynomial, draw them on number line, 0 and 2, plus, minus, plus. So plus to minus, that means which particular value, maxima or minima? This is the sign change of first derivative, right? So positive to negative is maxima, okay, and from minimum negative to positive it will be minima. Also understand, whenever you have a continuous function, Now let me explain it to your formula again. In terms of a continuous function, maxima and minima are adjacent. What do I mean by this? You cannot have two maxima simultaneously. So if one maxima is there, I can immediately say that the next extreme point will be minima. You cannot have two maxima or two minima right besides each other if the graph is a continuous function. Not possible at all. Okay, remember this property as well. So this becomes what? X equal to 0 is point of maxima. So just at maxima occurs at x equal to 0. What is the value at x equal to 0? 4 by 3. So the point we were looking for is 0, 4 by 3. That is the C option. So these kind of questions could be asked in exam, which actually involves integration, a bit of integration, application of the point in the curve, and then the concept of maxima. I hope the question is clear. So by this we come to the end of this particular concept, and we end the application of derivatives topic as well. I'll be mailing you the worksheets of maxima and minima as well. And this particular topic, if I talk about from the point of view of JEE Mains, is considered to be very easy, right? So what I have taught you in the videos is more than sufficient. This is considered to be easy and scoring topic, right? So you have to understand that do not waste your time in solving tough questions, because AOD at a JEE advanced level, if I talk about AOD as per se JEE advanced, right, it is considered to be a very tough topic. So according to this, it will be a tough topic, right? So people who are only targeting JEE Mains and not JEE advanced at this point of time, or even they are targeting JEE advanced but they are weak right now at this point and they want to focus and score more at JEE Mains, you should not do more of AOD than this what I have taught you in the videos. It's more than enough, necessary and sufficient conditions, remember. So this is more than necessary and sufficient for JEE Mains. In fact, what you can practice now is, apart from the worksheets, go through your NCERT book very well. It is a beautiful book which is given, right? And you have very important and good examples in this particular book. And if you are facing any difficulty, then you have the videos available on the channel itself, which you can watch over there. Okay, so I see you tomorrow again with the new topic altogether. All right, prepare the calculus part very thoroughly. This is the target of this particular week, and I'll see you with new chapter tomorrow. Good night for today.